Pranam Guruji, Pranam teacher. Today I would like to explain about the questions from the test. The first question is this one. Pak Gale is giving their students this series, this capacitor series, where there are 4 students who has their own role. The first one is Enda. Enda is calculating the capacitance of the capacitor. Era is calculating the total amount of electrical charge series, and Lulu is calculating the electrical force of the capacitor 6, this one, capacitor 6 micro F. And Risdiani is calculating the voltage of capacitor as well as this one also, 6. Okay, let's go to the first one, which is Enda. To find the whole capacitance of the capacitor, we have to calculate it in total, but with a small step and small step. The first step is this one. We see that this is a series, right? So if it is a series, then we calculate the total of the capacitor or capacitance is this by this one. 1 per C series equal to 1 per this one, 6, 1 per 10, and 1 per 15. Then we calculate it and then we find this number. 1 per series is equal to 1 per C capacitance series is equal to 1 per 3. So the capacitance of the series is 3. So we already got this one, but we haven't got the whole. Then again we depict the current situation of the capacity, where this one, the series, is 3, and this one is 30. It is a parallel series, right? So if it is a parallel, we can just add it. So the C of the parallel is 30 plus 3, which is 33. This is a 33 F. Okay. Then next, now we have made this into a wand. So the last sorry. So the last shape is like this. 33, this one, and 11 and 22. We got this 2 from this one, right? So because this one is a series, then we calculate the capacitance by this one, 1 per. Then we calculate it until we find the the capacitance. 1 per capacitance is equal to 1 per 6. So the capacitance of the capacitor on the series is 6 micro F. And then B, ERA is calculating the total amount of electrical charge series. So we now move on to ERA, because ERA is finding the total amount of electrical charge, because the formula for electrical the formula of electrical amount is Q equal to capacitance times voltage, because it is the total. So this one is Q total and C total and V total. We got the Q total equal to C total times V total. We have got the C before from Enda, right? And then we times it with the voltage of the series, which is this one, the voltage. The voltage is this one. So the answer is this one, 66 microcoulomb. Now we move on to Luluk. Luluk is finding the electrical force in capacitor C6. So first one, we go from this depiction where it's the same like this one, right? This series depiction is a series. Because it is a series, then the electrical force in CP, C in this one and in this one is the same with the electrical force of the total. And then we make CP this one, because this one is actually like this one, so is the same. This one is the same with this one. With this one, it's the same with this one. So because it is a parallel, then the voltage in this CS, and in this one is the same to the voltage in VCP. VCP is this one, voltage in here. So VCP is because voltage is equal to electrical force per capacitance. Then we use this formula, so this one. The QCP is equal to the key total, where the electrical force of the total is 66, and C parallel, capacitance of the parallel, is equal to 33. So 66 divided by 33 is equal to 2 voltage. Then, because we wanted to find the capacitance of this one, then we make this C capacitance series into this one, right? And then because it is a series, again same like this one, the electrical charge in 6, 10 and 15 is the same with the electric charge of the series. So we find the electrical charge in series is equal to the capacitance times voltage. The capacitance is CS, the capacitance of the series is 3, right? CS is 3. So 3 times by VCS, we only find here VCS is 2. So 3 times 2 is equal to 6 microcoulomb. Now we move to Rindiani. Rindiani is finding the voltage of the capacitor, same like Luluk here. So becomes this one. Because Rindiani is finding is depicting as the same as this one, right? Because if this is a series, then the electrical charge is the same as key series, electrical charge in series. Then the voltage is equal to key per V, same like this one. So KCS that we already found here at 6 divided the capacitance that we want to find. The capacitance is 6, right? So 6 divided by 6 is equal to 1 voltage. It's the voltage in capacitance micro F. So we got the answer where calculating the total of the capacitance. The capacitance is 6 micro F, and era calculating the total of electrical charge is 66 microcoulomb. Lulu is calculating the electrical charge in 6 micro F is got 6 microcoulomb, and Indiani who calculate the voltage in 6 micro F got 1 voltage, right? So this is the answer. It's a 3 charge. The first one is charge A, that is negative, charge B, that is positive, and charge C, that is minus or negative. Charge A is equal to 0.4 microcoulomb, charge B is equal to 1.5 microcoulomb, charge C is equal to 6.4 microcoulomb. The distance of Q and C, or x centimeter, is 4, and the distance to A and B is 3 centimeter. So first one, we draw what is happening, or the path of the force. The first one is path for FAC, force AC, because this one is minus and this one is also minus, so it will repel. So the path will be like this one. Because this is minus and this is plus, it will unrepel. So this will be this one, right? We already know the situation. Now we find each FAC and FAB. First one is FAC. FAC we find from this formula, and then key is 9 times 10 point to the power of 9, and this one is the QA, Q6, until we found the result is this one per x. I still use x here, but we can already make it 4, but it's okay with x. And then FB is the same, the formula. And then we find FB is this one. Okay, so because we will need to find the factor resultant, the total factor from the Fx, from the x, the factor is equal to FAC because there are no factor gain, and for the sigma Fy is equal to FAB. So Fx sigma Fx is equal to FAC, sigma Fba is equal to FAB. And then the Fa, or the total that we wanted to find, the amount of the coulomb force, we use this factor formula where Fa is equal to square root of sigma Fx to the power of 2 plus sigma Fy to the power of 2. Fx, we already find it, right? Fy, and we'll find it. So we'll calculate this one and this one. We calculate it by itself to the power of 2 to the power of 2. We got this one and this one, 5.29 and 5.76. And then we divide this one and also this one you got this number. So make this one and this one is the same, so this one is be like this, come like this, and it's the same, and then we add, so it's equal to 2.13 times 10 to the power of minus 6. The square root of this one is this, so this is the answer. Fa is equal to this one, Newton. Alright, we move to the third question. So there is two electrical force. So there is two Q1 and Q2 that is being separated by the distance of 4 meters, and there is a dot X that is near that has distance 1 meter between from Q1, because the magnetic area or metal magnet has to be 0. So EX1 it should be equal EX2, because then if we find the sigma E, we will get the 0, right? So that is why this one has to be the same. So first, before we calculate, we make the formula tidier. This one is equal to K times K1 per R, or the distance from X to K1, and this one is also the same, K times K2 per R2. Then we move R2 right here, and we move R1 right here. So it becomes like this, R2 times K1 and R1 times K2. R2, this one is equal to 4 minus 1, because this one is 1. It's equal to 3, right? 3 meters. So 4 minus 1 is 3. Is 3. No, so it's 1. Because this one is to the power of 2, then this one is equal to 9 K1 1 K2. So this is the ratio of Q1 and Q2. That is all from me.